Welcome to Futures Conversations, the Edinburgh Futures Institute podcast that showcase all the wonderful research taking place at the Edinburgh Futures Institute. Research at the Futures Institute is challenge-led and interdisciplinary, addressing many of the greatest challenges we face in the world today. I'm your host, Enda Delaney, the Director of Research at the Futures Institute. In this episode, I'm joined by Professor Sean Smith. Sean is Chair of Future Construction in the School of Engineering and Director of the Centre for Future Infrastructure at the Futures Institute. Sean, could you tell us a little bit about your background, where you grew up, who inspired you as a teacher, what values were important to your family and wider social group?
I grew up in Edinburgh and also Dundee and a small village called Errol in Perthshire, and very much enjoyed the whole idea both of living in a sort of urban and suburban and rural area. So I had the chance to sort of see all of that, and my family were all farmers by background. But I would say probably some key changes in terms of career path of, where was I going, etc. I was really struck by the whole construction industry and infrastructure, how it can change people's lives, the opportunity not just be at the desk, but be out and about visiting sites, and also the innovations that happen across that landscape. I was very, very fortunate. I did my studies at Heriot-Watt University, my first degree there in building economics and quantity surveying. Although I realised that quantity surveying wasn't for me in sort of cost calculations, I really enjoyed the whole architectural technology journey, learning about kind of noise and vibration in structures. And very importantly, we had a couple of lecturers who were very innovative, who worked really closely with industry. And they were very kind and took us sometimes on some of their projects they were doing with industry. And I think that inspired me in the end when I finished my degree, that I would then focus specifically looking at sort of the future of sort of noise and vibration in structures. That was my first point, and specifically around construction technologies.
I read somewhere that Lego was a key formative influence. I don't know if can you tell us a bit more about your love of Lego growing up?
Well, very much. I think for many people who are in the sector and beyond this in design and creativity and things, Lego has played an integral part of people's lives when they were young. The chance not just to obviously follow the build instructions and things of what you're building, but then to innovate and adapt and build and design your own structures. And I used to take great pride as a young boy. I'd run down the stairs and show my mum what I'd built with something that was not meant to be on the box, but it certainly looked quite different.
It sounds like that some of your teachers at Heriot-Watt actually inspired you to do what you do today. Were there any people in particular, or was it just the whole sort of ethos and environment?
I mean, there were several lectures. Hunter Cairns taught us on architectural technology, as did David Mackenzie, who also taught us about building acoustics and noise and vibration in buildings. And both had been involved in the development of new products for the construction sector. So that in itself, their background, their knowledge, how much they shared with us about their journeys with some of the products and where they were then being used, and also some of the testing and development they did. And I think that was a trigger point for me to get interested in research and development and R&D.
So within your sort of wider family and social group, was it unusual to go into academia or into what you do, or was that quite normal, or in the sense, did you stand out, or was this a sort of a predestined pathway for you?
Definitely wasn't predestined. Certainly I was one of the first or second in my kind of family generation, if you look across my aunts and uncles, of my cousins, of people who went to university. And the best advice I had was that nothing is set in stone. And I always carried that, thinking you will change your mind on things. You might change the career path, and I think I've changed mine 2 or 3 over the period. But everything has an inflection point where it comes back, when you think, I remember that particular moment when something changed that made you think about, that's a different career path.
So what was your route into academia and becoming a university professor?
Well, initially I came through, I would say probably the standard route. I started my PhD. The PhD went part-time when the mathematical models we were looking at to predict noise and vibration in buildings, those mathematical models we could take to any structure. All we could change was the material properties, but the actual noise and vibration, the waveform, etc., the frequencies, etc., where things occur. We can change that with a mathematical model. And so that was very attractive to the Ministry of Defence and the Defence Research Agency. They really liked our complex models. And so I started a research fellowship working for DERA, the Defence Evaluation Research Agency, for 3 years to predict vibration in complex structures for helicopters and aircraft. I was very fortunate. We had a tremendous mentor from the Defence Research Agency. Sadly, he's passed away now. But many people might have seen James Bond and know Q, the inventor. And of course, Ian Fleming, the writer of Bond, based so many of Q's attributes on what we call SSOs, who are the senior scientific officers of the Defence Research Agency. And in fact, there are 6 senior scientific officers, and I worked for one of the senior scientific officers. So if someone had told me as a young boy watching James Bond that later in life I'd be working for the equivalent of Q, I think I would have burst out laughing.
Yeah, I could imagine.
So I came through that path, finished the PhD, finished the research fellowship contract, and then had the chance to go overseas. I went to work partly in Canada for the Canadian government, the construction research laboratories. And then I spent 18 months in Italy working for the Italian government in Turin, in Torino, which was a wonderful opportunity. And then following that, I went to work for the German government research laboratories in Braunschweig at the Physikalisch-Technische Bundesanstalt, which is the state government science and physics metrology centre. I mean, in all the projects I've been involved with, whether it was Canada, Italy, Germany, my work when I came back to Scotland, where I joined Rob Mackenzie Partnership, it absolutely influences everything I do. And one of the exciting things is you see the challenges that the industry has in construction and infrastructure. You see the pressures they're under for material resources, to do things better, to improve circular economy. We use circular economy today very much as a standard term. It wasn't a term used by the industry many years ago. It was just about waste reduction and trying to reuse the optimum materials you had. And in many cases, reuse buildings through conversions and change of use. And I remember one of the first big conversions I was on was an old church building and an old convent. And it was amazing converting that into apartments and working with the architects and designers. I've had the great fortune to work with great research colleagues, and we've developed 5 patents, and we have 17 patented products in the market, which are manufactured in the UK and sold and owned also by multinationals.
What does your field, which broadly we could describe as future infrastructure, what does that encompass? How would you explain that to a non-expert?
Well, infrastructure in the round is almost everything around us, from the physical man-made elements of transport, buildings and roads, etc., through to power lines and infrastructure that supports our energy infrastructure, but also looking at some of the natural infrastructure. For example, the use of forests and how we can bind soils and reduce, for example, slippage in embankments or hillsides, etc. Right through to marine preservation and coastal protection, and also specifically and more importantly, recently addressing climate change. So the actual role within infrastructure is multifaceted. And that's a perfect reason why it should be based in the Edinburgh Futures Institute. I
was fascinated reading about you, the work that you did on medical acoustics and preterm infants, which I know was an earlier stage of your career. Could you tell us a little bit about that? It seems a very practical case of where high-level research informs actually improving people's lives on a day-to-day basis.
Yeah, it was a really interesting piece of work. Going back a wee while, this is when I was in an acoustics research laboratory at Heriot-Watt. We have what's known as anechoic chambers, and anechoic chambers is where no sound or vibration can enter or exit these test facilities. So it's a great way to measure directly how sound travels from one source to another. And we had a visit from a series of teachers who were teaching various projects that the university had been linked to. And we thought it'd be nice to bring the teachers in and show them the facilities. And they walked into the anechoic chamber, and 2 of the teachers immediately felt unwell and had to leave. And both teachers, we subsequently found, had a hearing deficit. 2 weeks later, we had a visit from school children who were profoundly deaf. And when they went into the anechoic chamber, all of them immediately felt unwell. It was almost as if we'd taken away any natural stimulus that was around them. And we jump forward about 4 or 5 years, and I'm now working in Italy. And there'd been discussions of how we'd had visits from to a colleague of mine, visits from the medical experts in Turin and also from Rome, who were looking at the opportunities of when the fetus is in utero, in the womb, the opportunity and the importance of the mother's voice and voices which penetrate it. They had seen and it had been reported that there was better ventilation, better respiratory, or better receptacle to this kind of stimulus, this natural stimulus of frequencies. And that very same day, there was an article about what they call La Morte Blu, which is also described as SIDS, or sudden infant death syndrome. And the issues around children these young infants who are generally 3 to 4 months old, who commonly have issues of influenza B, for example, type of flu, or other issues when they have cot death or suffer from that terrible tragedy. And that very day, I had the most horrendous cold. I was coming down with the flu, and my hearing was affected. And I reminded myself of the issues of the deaf and the profoundly deaf going into the anechoic chamber, how we'd stripped away any natural environment. And when you looked at a lot of the guidance for infants to parents to avoid preterm deaths, such as sudden infant death syndrome, then the issues around audibility, hearing, synapses, etc., and things like don't cover with lots of materials, blankets and pillows. These are highly absorptive, and it started me thinking: is that eighth cranial nerve, is the auditory nerve more important than we think? And we often hear about people saying that when someone's in their last phase of life, they may not see you, but the likelihood is they will hear you. And therefore, is it one of the last parts of our primary system to shut down? And we know it's linked to the thalamus and the hypothalamus, and that controls our natural body mechanisms such as breathing, etc. So I raced home and went home with several books and papers, and hid under the covers as I recovered from the flu myself, and read back to back all these papers. And on the Monday morning, came back in and met my colleague who had met with the medical experts. And I said to him, I needed to sit down. And we drew up on the whiteboard. And I showed him this pathway of how auditory sound could influence various things and cardiorespiratory function. And actually, it could be more important than we thought. And following that, we then contacted researchers in New Zealand, a wonderful researcher called Malcolm Stewart, who at that time was in USA. And when we sent him our kind of concept theory, he was delighted because he had worked in a similar area. And we had synergy. And so we then read about 400 papers and then summarized that. And then the paper was published in the journal, International Journal of Prenatal and Neonatal Medicine. One key bit of advice was, and this was very important, was that it was important we felt for the infant to be sleeping in the same room, not the same bed, but the same room as the parents, because there's a natural stimulus when the parents are in the same room. They're breathing and other sounds. And obviously all the advice about the position of the baby, etc., the back to sleep campaign, all our areas agreed with that, because if you're not on your back to sleep, if you're on your side or your front, you will attenuate the auditory nerves function, etc., and the blood flow. And so we'd recommended that. And so shortly after that, there was a major international study that then followed that up. And then the advice came from that, which is printed in all the newborn leaflets for parents. It's strongly advised that the infant for the first 6 months sleeps in the same room, not the same bed, so the cot can be near the bed. And that's been advice ever since. So I think we were part of, let's say, a series of people at that time who were very focused on that area. And I wouldn't say we led it, but I would say the fact that the press coverage we got from both the BBC, international newspapers, when the journal got published and our article, drew a lot of attention to the area. And that, if anything, I'm delighted with.
Could you tell us a little bit more about how your research has informed sound insulation in domestic homes in the UK and internationally? Could you tell us a little bit about that?
Sure, delighted to. So when I was doing the PhD looking at sound and vibration in buildings and structures, that is all part and parcel of looking at the overall sound insulation which you have between housing. So this is what we call attached housing, like terraced or semi-detached or flatted or apartment type buildings. And there's some key regulations and standards. Now, those regulations and standards do vary between countries, but nevertheless, they're important because there's a quality of life aspect. Interruption to sleep or other things through, unwanted noise or unwanted sound, such as noise, is a real issue, particularly for young children and also for adults, because it interrupts your sleep patterns. And what happened was, from the work we were doing, the English or UK government, but English government were changing their building regulations. And at that time, they had proposed a brand new criteria for how you measure sound insulation. Quite different to anything no one else in the world was using at that time. And they'd sort of almost taken a different standard for a completely different aspect and brought that in. And the house building industry at the time were quite concerned that how were they going to address this new criteria? How do you meet this new sound insulation? And how do you design for it? How do you build the walls and floors that divide all these housing and apartment units to meet the new criteria? And we were very fortunate, and this is where data is key. We were sitting at the time in our university, in our research facility, and also with the Rob Mackenzie Partnership, on a lot of field test data. And so we proposed it would maybe be useful to look at an alternative approach, which is where you can actually design in enhanced sound insulation. So you build well beyond the standard. And you're not going to have to do that test of compliance. And that was the big issue the industry was facing in England and Wales. How do you test and comply if there's not enough testers? And if you're actually building very similar archetype type approaches in new build of housing and the type of construction, how could you in fact standardize that? And so we won the contract to investigate and develop that. The government gave the industry 12 months to deliver alternatives. We told the industry statistically you need to test every wall and floor, different construction, different houses, but the same design 30 times to have statistical significance. They loved us for that one. And then we proposed a series of constructions for them to build and test. And it was through the Home Builders Federation, and that was all the major and medium-sized house builders across England and Wales. They absolutely rallied to the fore. We assembled 5 working groups, 119 committee members. We issued the designs within 6 weeks of being appointed on the project, and they built for us 1,400 brand new homes with the designs in 6.5 months, all tested. And again, thanks to Building Control, the local authorities, the warranty providers, because they had to accept our recommendations for these new designs. And we were delighted to see the government then adopt that approach. The industry, we designed it into a handbook and published it. And the government then decided, instead of just a one-off handbook, let's keep this live. And let's allow new innovation to come forward. So an organisation was set up called Robust Details, and I was initially director of that to get it going. And I rejoined the company back in 2017. And it's a wonderful opportunity how you could create a modal shift for the whole sector, supporting evidence, underpinning data, standardised approach. And over 1.6 million homes have now been built with those designs.
Have our attitudes toward what you might call noise being seen as a disturbance, have they changed over time?
I think they have. I think partly maybe because of the source of noise. If you go back to the 1990s, the main driver behind England and Wales changing their building regulations and improving sound insulation levels was because of the number of complaints went up 4-fold in the domestic sector. Not commercial, not environmental noise. It was the housing sector. So many people were listening to bass music, garage, rave, etc. And that probably really sort of infused the government to say, we need to address this. Now, we cannot do it retrospectively in the existing stock. It's not a health and safety aspect. It's not a structural issue. But we can do it for new build. And that's why when they designed this new criteria that they brought in, they made a big focus on lifting the requirements of the minimum amount of insulation you need at low frequencies, which we had to design to meet.
In the past 15 years or so, you've very much concentrated on sustainable construction. What are the challenges that we face in our efforts to achieve net zero emissions?
As we look to the future, one of the issues is that the global population will rise from about 8 billion to about 11.3 billion by the year 2100. That's going to place huge resources pressures on materials, land availability, etc., but particularly on materials. And so to meet that demand, we will need to build, over the next 75 years, 1.2 billion homes. Now, in addition to that, people are also living longer, which is wonderful. You know, fantastic health facilities, and as more and more countries improve their approach to health and solutions that they have, so more people around the world will live longer too. And what that does do, though, is it then, as more people are living longer, it reduces the supply of housing coming back onto the market, and also, sadly, with divorce and other things. And so you need new households to support. And this puts huge household pressure. So we need another 800 million homes over the next 75 years if this trend continues globally. That's 2 billion homes. And the pool on material resources around the world will just be huge, if it's not already. So it's incredibly important we do things as sustainably as we can. We reutilize materials, we look at design from the very first thing that we do, right from the design stage. How do we maximize that delivery, but reduce that effective footprint of materials and resource? And net zero, which is a separate but almost equal challenge, has had various, let's say, journeys of different play in different countries. The UK, we for example, in construction and housing, we devolve the targets effectively that we're looking at. Specifically, the Scottish Government has its own targets, but nevertheless, it will still wrap into the UK targets. So the Scottish targets are 2045 for net zero. UK targets, most of European targets are 2050. And whilst across the UK, we have reduced the overall emissions by about 53% since the 1990 levels to where we are now today in 2024. We're in that tough period where we've not really reduced effectively for housing. We've not really reduced effectively for agriculture. And our transport emissions make up 25% of the emissions that we currently have. And that's another key target. So the amount of work and graft to do over this next 20 to 25 years is significant. And we're in, I would say, the difficult stage because we've done some of the easy bits, we've done some of that low-hanging fruit, and we really need to up the game and accelerate as quickly as we can. And finally, I would say, it's not all about data and technologies. We need to take society with us. I mean, for example, 2 years ago, if you wanted to do some sort of green measures on your home, there are about 7 or 8 different types of funding stream and different funding aspects from governments, depending on what you were looking at. And that was very complex for people. So I think we need to streamline it, simplify it. Just looking at Edinburgh and Glasgow alone, just take just the housing. Forget transport and everything else. But just to retrofit where we are, that's a £35 billion market over the next 20 years. Scotland needs to retrofit roughly about 135,000 homes per year. England needs to retrofit approximately 900,000 homes per year. And Europe needs to retrofit every year till 2050, 11 million homes per year.
I think this takes us to your role within the Futures Institute as Director of the Centre for Future Infrastructure. What does the centre do?
Well, the centre really acts as a bridge between many of the aspects happening in engineering across all areas of engineering and also within the College of Science and Engineering, and linking right across the university. So very much the EFI, the Edinburgh Futures Institute model, the Centre for Future Infrastructure, by being based there, its purpose is to look and solve and work with interdisciplinary teams. So that's working with architecture, it could be the law school, it could be geosciences, it could be social sciences or humanities, it could be the business school. So the purpose of the centre is not to run out and get lots and lots of academic research staff. The purpose is to link across who are our experts, where are they in the different schools and research institutes across the university, where we need them to come together and be that interdisciplinary team. I mean, just some examples of projects. We've worked with geosciences and architecture, looking at projects around Dubai. Similarly, we've worked with similar diverse schools around projects looking at sustainability in Galapagos. We've had projects recently in South America, where they're looking at issues around new infrastructure for dams and also the issue around the legal aspects for that. So it's quite a diverse but a wonderful area to be in, because infrastructure touches so many areas. It's almost a keystone. We take so much of it for granted, but nevertheless we use it day in and day out, and it plays such a critical role. So that's the purpose of CFI, to go after some of these key challenges around climate change and infrastructure, particularly resilience, but also to bring all these different partners together, all these diverse and wonderful academic colleagues that we have at the University of Edinburgh, and also work with industry, public sector, whether it's advising on future skills pathways, which we've been doing for the region and also for the UK, where it's looking at the opportunities around new skills that will be needed for the future, the new technologies which are coming. So we're assessing some world firsts and new heating systems that are coming to market, which is very exciting, but also listening to the societal needs and that sort of touchstone of where is society going? Are they on side with us, with where we're trying to get to? What could make it easier, and how do we infuse them to stay with us? And when people were saving many years ago and planning for their pension, they probably hadn't planned that they might have to spend £15,000 or £20,000 retrofitting their home, and an additional maybe 20 or 25,000 over and above what they were expecting to pay for an electric vehicle, in addition to installing electric charging points, etc. So it's a new dynamic, it's complex, it weighs heavily on some people's shoulders how they might afford that. And so we need to make sure that we are, one, simplifying that process, innovating to reduce the costs, and improving how people will interact with that and take it forward.
Where do you see political leadership featuring?
This is something, because it's 2045 or 2050 deadlines for net zero, this is not something that's a 4 or 5 year political cycle. This is something you invest in now for the future, and none more so than skills. We need a kind of joined up approach across government in construction, and that has perhaps been lacking a bit. I saw many years ago a very good model. This is about 15, 16 years ago. I won't say where, if that's okay, but there was a government department we were working with where they had basically a very, very senior civil servant who led construction. And whilst the sector was, crisscrossing 6 or 7 ministerial portfolios, he linked everything together and tried to make sure there was an association or link with that. When he left, he wasn't replaced. And suddenly there was a loss. There was no construction minister either. So there's no one to drive things forward. And we've seen both in the 2013 review, for example, of the review of procurement in construction, they recommended having a construction czar or a minister for construction. And I did a review for the new housing skills for future new housing. And one of the 40 recommendations there was we need a construction minister or a senior construction czar who's in the civil service, because it's so important. To get to net zero, construction and infrastructure is absolutely paramount. And you can't have so many things crisscrossing 6 or 7 government agencies with no connected tie-up.
You were very recently awarded a large grant from UK Research and Innovation, and congratulations on that, for a new centre for net zero high density building. How do you think this funding will transform practices within the construction industry?
We're in some pretty difficult times when you're looking at net zero. The reason that we looked at the high density buildings is, let's just take Edinburgh and Glasgow. They are 68% and 73% flats. So the highest proportion of flatted or apartment dwellings in the UK. London's about 52%. The UK average is 20%. And Scotland naturally has a higher average, about 38%. But nevertheless, the complexities of dense streetscapes, different types of archetypes of buildings going back 400 years, stone developments, etc., traditional, historic and listed, plus the complexity of bringing in perhaps future district community heating, testing new technologies, the skills and the data required for that, and also that occupant interaction behaviour. That was the foundation of setting up the centre. So we could have multiple work streams that were talking to each other, new heating technologies, new materials, green approaches, archetypes, district community heating, sensors, etc., and skills. And for the sector itself, the sector is striving, it is innovating. Where it can, it's testing and developing, and they need support. And that is the role of this centre. The centre will support the industry, both public sector, private, commercial. It goes beyond just housing. It's going to look at non-domestic as well. And it will also, as we're currently doing, working with new housing. For example, the Edinburgh Home Demonstrator down at Granton is one of the sort of real pushers of the envelope of where we're going with net zero for housing. And it's great to be involved with that. And in the future, that could be a major test bed for so many of the things that are to come. But we think it's very important having such wonderful partners. So it's Edinburgh's leading it with Glasgow University, Strathclyde University, Napier University West of Scotland, and we're working with the industry's forerunner in innovation and development, which is known as BEST, Built Environment Smart Transformation. We have 58 partners. That's given me a few grey hairs drawing them together from public, government, social housing, industry, manufacturers, etc. And I think collectively that 4-year project, all being well, every few months we'll be pumping out reports, knowledge exchange and workshops to accelerate that delivery of net zero for this really important area, which is high density buildings and cities.
We're here in the Edinburgh Futures Institute. What sort of future do you envisage given your expertise?
Sometimes people ask me, what gives you sleepless nights? And I'd say the whole issue around building in the resilience we need for our infrastructure with climate change. I think we've seen with the recent tragic events in Valencia in Spain, Malaga, Barcelona, Italy with similar floods, this terrible storm Boris this summer in Europe, which impacted 7 countries, and the scale of flooding. And basically our roads are turning into rivers. They have become the conduit for most of the floodwaters now. And the damage to people's lives and property is so significant, and the intensity is increasing. So we've seen a huge increase in the intensity and also the number of storms in terms of that intensity in Europe. In America, they classify as billion-dollar events. And back in about 2003, they had 2 or 3 events. In 2023, they had 23 major billion-dollar events due to forest fires or flooding and storms. We saw with Hurricane Helene in the USA, the whole issue there of absolutely everybody was right to focus on storm surge, the Florida Panhandle. I think no one could quite foresee with suddenly that slow movement of the storm as it sat over the states further to the north, like North Carolina, the sheer scale of damage that would ensues. And then more recently with the other one with Hurricane Milton, which crisscrossed the panhandle of Florida, and everybody did the right thing. They got out of this is going to be the pathway. Okay, we'll get out of that pathway. We'll move north or south. But no one could have foresaw we'd have 140 tornadoes to the south of the hurricane pathway, where people thought they would be more safe, but in fact turned out to be more dangerous.
Thank you very much, Sean, for coming in to tell us about your fascinating work.
Thanks very much, Enda.